everyone, and welcome to the last session in this A4 room. Now we're going to talk about microservices, about whether to use a central or decentralized approach. Let's welcome Mete.
Thank you. Hello, everyone. First of all, I'm very happy to be here after 2 years of 2+ years of lockdowns and everything. Jfokus is very special for me because it was the first conference I came as a Google employee in 2016, and now it's the first conference that I'm presenting in person after 2+ years. So I'm very happy to be here. Thanks for being here. And it's the last talk of the day, so I know it's been a long day with great sessions. So I'll try to go as fast as I can so that we're on time for the party afterwards. So as you can see, I crossed the serverless micro part and then changed the talk to choreography versus orchestration in services, because I realized that all of the stuff I'm talking about, it applies to any kind of service. It doesn't have to be serverless, it doesn't have to be micro, it can be monolith, it can be whatever. As long as you have services, you can apply these concepts. So that's why I wanted to just change it slightly. And by the way, the presentation is already on speaker deck, so you can grab it there. You don't have to take pictures if you don't want to. And I'm going to start with some slides, so the beginning will be a little bit of slides. But don't get discouraged if you're looking for code or samples. I'm going to have that in the second part of the talks. And the code and everything else will be online as well on GitHub. So everything that I'm going to show today, both slides and the code, is available to you at the end of the session. And I'm going to share the links at the end of the session. All right, and then feel free to ask questions as we go along, because it's great to have in-person presence. And if you have anything that comes to mind, feel free to ask. All right, first of all, what do I mean by choreography and orchestration? Let's go through that a little bit. Now, imagine you are building an e-commerce application. And typically in an e-commerce application, you want users to buy stuff. So, and this is a simplified version of that, but let's imagine that this is how you are building it on somewhere like Google Cloud. What you might have is a series of microservices, right? So you might have a front end that's typically written in App Engine. Then you might have a payment processor that processes the payments running Cloud Run, which is a container service. Then you might have a shipper that might be written in a Cloud Function. And then maybe you have a notifier to notify the user that the e-commerce transaction is done, again using a Cloud Run. Now in this scenario, what you have is you have separate services doing different things, and they're calling each other directly, right? So the front end calls the payment processor processor calls the shipper, so on and so forth. So what are the pros and cons of this approach? What I call this simple REST-based approach. Well, first of all, the pros is that, you know, instead of having a single monolithic kind of application that we used to have with J2EE and WARS and EAR applications, you have multiple services that are doing their own bit. So for many reasons, that's better because you can reason them, you can test them easier, and you can update them individually, stuff like that. And these services, they're easy to implement. All you need to worry about is, you know, here's my service, and here's what it needs to call the next service in the chain. Now, on the other hand, there are cons. First of all, you have too much coupling. So each service has to know the next service in the chain. And that means that every time you change a service, you need to think about who's calling this service and who this service calls to. So there's too much coupling already. Each service can be a single point of failure. So if there's a payment processor and it goes down, then the whole chain kind of breaks down. And each service needs its own error read-write timeout logic, right? So if something goes wrong and you want to apply some kind of a read-write policy, you need to implement that somewhere. And typically, I mean, maybe you have a library to do that, but you need to use that library from each service. And for me, the biggest problem is that who ensures that the whole transaction is successful, right? I mean, each service might be working correctly, but maybe the transaction doesn't work, or if something goes wrong, who makes sure that things are read-write, right? And there's a hint here, there's something called Saga pattern that helps here that we'll talk about later. So that simple REST-based approach is easy to reason about, but it doesn't really work at scale. What you could do, you could try what's called an event-driven approach. It's also called choreography. And the reason for that is that, you know, each service does its own thing and they just generate events, but they don't actually know about the next service in the chain. So in this model, you typically have a message broker or something like Kafka, or on Google Cloud PubSub, and then the front end still receives the request, but instead of calling the next service in the chain, it will generate an event, and the event will say something like, I received this order with these details, and it will pass that message to the message broker. But then message broker will figure out where to route that message. So the order message will go to the payment processor because that's the one that's registered an interest. It will receive that message, and it will send another message saying, okay, I processed the payment process message, and it will send that message, so on and so forth. Now in this model, each service is independent. They don't know about each other. They don't care about each other. They just emit messages and then also subscribe to messages that they care about, and message broker is the one kind of passing these messages around. Now, what are the pros and cons of this approach? Well, first of all, services are much loosely coupled. They don't care about each other, and they don't need to. Secondly, services can be changed and scaled independently, much easier than the simple REST-based approach. You don't have a single point of failure in the sense that if a service goes down, the rest of the services still works, and the rest of the services still kind of send and receive messages, but your whole transaction is still might not work. So this is a good thing, but not so good. And events are really useful if you need to extend your system. So if you need to add a new service, all you need to do is that deploy that service and figure out what kind of messages that service is interested in, and that's it, right? So you don't need to worry about the rest of your system. You can just add a new service pretty easily in event-driven systems. Now, on the other hand, this is going to be more difficult to monitor, because what you have is that you have all these services sending all these different message types, and if something goes wrong in your system, where does it not work? How do you trace that, and how do you kind of figure out what message was not consumed or what message was sent, but it wasn't received by some other service? The errors, retries, and timeouts that we talked about, they are still a problem. You still need to think about them and implement them somehow. The business flow. So in our REST-based approach, there was this flow of services, and it was really easy to visualize. But then once you have event-driven, that flow is not captured anymore. You just have these services kind of laying around, sending messages, but that flow, there's not a central place to capture that flow. And this problem of who ensures that the whole transaction is successful is still a problem. So things are loosely coupled, they can be scaled and all that kind of stuff, but you still need to make sure that that transaction across multiple microservices is still successful. And again, Saga pattern will help for this. We'll talk about that. And imagine you have a more complex transaction. I mean, typically, what I showed is a very simple example, but typically, what you probably want to do is that you want to, when a user sends you an order, you want to probably check a database, and then and after that, you want to check if you are in stock or out of stock. And then if you are out of stock, you maybe want to call a third-party API, and then once that's done, maybe you have another inventory order database, and maybe for the notification, you use something external like SendGrid. So this is typically what kind of flows that we have. And taking this and trying to make this event-driven, it is possible, but it's not going to be that easy. And also, when you look at this, it might be a little bit complicated, but you can reason through it. It's very clear what should happen. But taking this and again changing it to event-driven, you will basically lose that information. You will lose this flow chart basically. So your business flow is not going to match to your architecture, and that can be problematic when you're trying to reason through your system. So what you can do is you can also use something called orchestration. And the idea of orchestration is that instead of services calling each other directly, or instead of services just emitting messages, you have an external service. And this service is called an orchestrator that will define how things should be called, and it will make those calls on your behalf. Now, in this model, you will receive orders again from the front end, but the front end will basically kick off an orchestration. And in this orchestrator, you have some kind of definition of how things should be called and in what order. So the orchestrator will first call the payment processor with the details passed from the front end. Then the payment processor will happen and then send a result back. then orchestrator will take that result, and then it will call the shipper with those results, and so on and so forth. Now, again, there's pros and cons. Nothing is perfect. The pros of orchestration is that now you have a central place where you can capture the business flow. So this, order of the order of calls in your system, you can actually capture that in this orchestration or workflow definition. And I'm going to show you an example of this later. And this is very important because it allows you to do many things, and it really simplifies a lot of things that we'll talk about. Secondly, you have this notion of steps in orchestrators. So you have steps, and you define what happens in each step. And these steps can be monitored, because in your orchestrator, you will see which step you are in. And if something doesn't work, it will be really clear. This step failed, and you can just zoom into that part. These errors, retries, and timeouts, now you can centralize them. Let's say you want to introduce a policy that says, if something fails, and if it's this HTTP code that's a transient failure, then I want to try it 3 times before concluding that that service is down. You can do that in the orchestrator. You can specify that as part of the step, and in that step, if that step fails, the orchestrator will apply these policies for you. So you don't have to implement this in your code, and you don't have to implement it in every single service. Instead, you can do it in a central kind of place. And your services are still independent, right? So you still have, not microservices, you still have services that are independently deployed, but you are kind of bringing them together into what I call a temporary monolith, basically. So you're saying these services are independent, but I want them to be called in this order, with these parameters, with these errors and retries. So you're creating a temporary monolithic application for your use case, but you still have the benefits of independent services. Now, on the other hand, the cons is that an orchestration service, it's something new to learn and maintain, so it's something extra in your architecture. Orchestrator could be a single point of failure. So if orchestrator doesn't work, nothing works. So you need to make sure that you're using something resilient and redundant, and we'll talk about this in terms of what options you have. And you are losing the flexibility that comes with eventing. So I told you that in eventing, if you want to introduce a new service, you just deploy that service and you just configure what events it needs to consume. Whereas in orchestrator, you need to deploy the service, you need to change your orchestration, you need to use that service in your orchestration, and you need to redeploy your orchestration. So that kind of makes things a little bit less easy to change. And you still need to worry about failed steps. So in orchestrator, you have these steps, and you can easily see if a step failed, but then what do? You can't just let things just fail. You need to take what's called compensation steps to fix that step, basically. And this is part of Saga pattern as well. And with orchestrators, this is pretty easy to do, and I'm going to show you an example of this later. So what's better, choreography versus orchestration? And as in everything in our field, it depends. I think if your services are not closely related, so they're quite independent, or they can exist in different contexts, then usually event-driven architectures are the way to go. At the same time, if your services are closely related, meaning they usually are deployed together in a certain order, then that's when I start thinking about orchestration. Because if they're always deployed in a certain order, and if they always call each other in a certain way, then maybe you don't need the flexibility of event-driven architecture. Maybe that's an overhead, and instead you can think about orchestration. And also, if you can define your business logic in a nice flow chart, that like I showed you earlier, it would be nice to keep that logic and kind of translate that into an architecture. And that's what orchestration allows you to do. You can actually literally take the flow chart and create a workflow out of it and visualize it and kind of maintain that useful information. You can also take a hybrid approach, right? You can kind of combine things that make sense into an orchestration. So things that are closely related, that go together, they can go into an orchestration. But once that orchestration is done, it can signal other orchestrations using eventing, because orchestration A does not need to know about orchestration B. It just needs to signal that I'm done do whatever you need to do. Or similarly, maybe the orchestration is triggered by an event, right? Maybe some user saves a file to a storage bucket, and that triggers an event, and that kicks off your orchestration. So this hybrid approach, I think, what I mostly see, you don't use one or the other, but you usually use whatever makes sense in the context you're dealing with, and then you kind of mix and match both approaches. All right, so that was a really quick introduction to choreography and orchestration. Before I talk about the landscape in this area, what tools and services exist, first of all, I want to see if anyone has any questions. Any questions so far? Yes?
Can you say anything about scalability?
Scale. How does orchestration scale, or? Right. Well, it depends what you're using. I guess so. For example, for event-driven architectures, if you're using Kafka, then Kafka can handle a lot of messages at high scale. So at that point, I don't think you need to worry so much about eventing scaling. In orchestration, what I mostly know is Google Cloud's orchestration service called Workflows. And Workflows is also highly scalable. It can handle millions of steps per second. So it's highly scalable. But if you're using something else, I don't know. Like, you need to kind of figure out what the scalability characteristics are in that case. So I don't know. There's no basically one answer to that, I guess, with orchestration. Any other questions? Yes? Why only communicate in past tense? What do you mean?
Events is only the things that have happened.
Right.
It cannot be the only way of communicating, right? Because if you only do past tense communication with choreography, you can't tell somebody to do something or to get something. Whereas those are still valid messaging, basically.
Well, I guess it depends how you define your events. I mean, when you receive an order, you process the order, and then the event could be, order processed, and that signals. Yeah, that's still past tense. But I guess you can have another event that says, do this, with the event. It is possible to have future-driven events. I don't think there's my example was mostly past tense driven, but it doesn't have to be that way. Yes. All right, so let's look at the landscape in this area and really quickly. So when we are talking about event-driven, I mean, this is not an exhaustive list, just to give you an example. We have many options, basically. If you're on AWS, Azure, Google Cloud, or open source, there's a lot of options for event-driven. I just wanted to put some, names here so that, if you're working in these cloud providers, you know that there's these services to use. Orchestration is more new, so because of that, there's less choice. On AWS, there's step functions for orchestration. Azure, there's logic apps. Google Cloud, there's workflows for service orchestration, but there's Cloud Composer for data orchestration, and there's Apache Airflow for open source. That's Cloud Composer is based on. So these are the main tools. I'm sure there's more. I'm just giving you a few samples. And I actually looked into how these orchestration tools differ between cloud providers. So I looked into step functions, logic apps, and workflows, and I looked at some of the main features that they provide. I'm not going to go through each feature, but what I want to show here is that if you look at the basic features that you expect from orchestrators, they mostly are supported on on all platforms. If you look at more advanced features, then Azure Logic App seems to be the one that has the most features, followed by workflows. And then AWS Step Functions seems to be more geared towards AWS. So if you're in the AWS ecosystem, it's great. But then anything beyond that, then they don't have much orchestration options from what I see. So the basics are there, but depending on what you want to do, you probably want to check whether that's supported or not in the orchestration service that you want to use. And there's also an open source project called CNCF Serverless Workflow. And this is a specification for defining workflows. Also, SDKs to define these workflows in different languages, the workflow runtimes, And also there's some tooling around this. So this is a new project. I think it's been around for like a year, maybe a little bit more. That's coming along, and unfortunately none of the cloud providers, they support this yet, but it's something that's being developed, and something that's good to keep an eye on, because maybe at some point there will be different workflows or workflow services that will be, you know, running on different clouds, but based on this open source workflow definition and the runtime. All right, so that was the landscape. Now I want to look into an orchestration service from Google Cloud. And the reason why I want to show you this is not to tell you to use Google Cloud Workflows. Don't. I mean, it depends on which cloud provider you're using. But I want to show you what kind of things you can expect from an orchestrator, basically, by giving you some examples so that you can see how these things work in practice. Now, what is Google Cloud Workflows? It's a service to orchestrate and integrate other services. If you have code running in the cloud, in a cloud function or cloud run, you can use them in your orchestration. If you have APIs, if you want to call it Google APIs, for example, like Vision API or Gmail or things like that, then you can use those in your orchestration. And you can even include external APIs. Any kind of public API or any API that you can call from Google Cloud, you can include in that orchestration as well. And the nice thing about this is that, you know, usually when you want to run some code, it's not just about your code. It's about your code, the APIs that you call, and the external APIs that you call. So you can combine all of those into an orchestration using workflows. Whereas in AWS step functions, for example, I don't think you can include external APIs. So that kind of limits on what you can do with that. And actually, let me show you an example before going into slides. So for example, let's say you want to do some kind of service chaining. So you want to call like services that I showed you before, like in some kind of chain. Let's see how we can do that in workflows. So let me make this bigger. All of this stuff is open source, by the way, that I'm going to show you the link later. But what I want to do here is, let's say I have like 3 or 4 different services that are running in different places. And all I want to do is I want to call this service, then call that service, then call that service, and then just get the result in the end. So how would you do that in a workflow? Well, first of all, these services, the first one is what's called a random gen. It's a random number generator. It's a Google Cloud function, so I deploy that. I'm not showing you the code because we don't have time, but it just basically just generates a random number. Now the second function, it's called multiply. So it gets a number and just multiplies that with some number. Or I think you pass that input by 5. The third function, it's an external function from math.js, which is an external mathematics service where you can pass in an expression. And what we want to use it for is for log. So I want to call the log function and pass in this number as well. And then the fourth function, it's a Cloud Run service, which is a container service. So it runs a container instead of a function. And what it does is that it takes the floor of a number. So it takes a number in decimal points and makes it like an integer, basically. So you can see that here we have 2 cloud functions, 1 external function, and 1 container kind of function. And how do you bring this all together? Well, you create a workflow definition. And actually, let's show it here. So in workflow, you define steps. And here, I define, and you can name these steps as you like. So here I'm saying this is random gen function. Well, I should call this random gen step, because that's what it is. And then you define what happens in this step. We are saying that I'm making an HTTP GET call, and I'm calling this URL, which is the URL of the cloud function. And I am capturing the result of this call into a variable called random gen result, right? So what this means is that, you know, the workflows will make this call to this function, and it will capture the result in this variable. Next, I call my multiply step. In this step, I am making an HTTP post because it's expecting post, and it's calling the cloud function for that. And then it's passing the input from the previous result. So it's getting the result from the previous step, and then parsing the body and getting the random from the body, which has the result that we want. And then it passes that into the multiply function. Okay, and that will be captured as multiply result. Next, I want to call the logging function, but logging function is from this math.js. So I'm calling math.js This is the base URL. And then I'm passing in a query expression. And what this basically does is that it takes the multiply result from the previous step, gets the body, gets the multiplied value out of it, and then it passes as log of that to this URL that I'm calling. Once that's done, I get the log result. And finally, I want to call the floor function. This is another service, but running on Cloud Run with HTTP post. So I make that call. I'm passing an authentication here. And I think it's a private function. That's why I need to pass this authentication flag. And then I'm just passing the body of the result from before. And that will make the call to the floor function. In the end, I have the floor result. And at the end of my workflow, I want to return the result. And in this case, the result is just the result of the floor function, basically. So you can see how we are chaining things together in a kind of intuitive way. And it's easy to kind of call things and get the result, pass on to the next step, stuff like that. And just to show you how this works, I have hit deployed here. Let's see if I can find it out of all this stuff. This was service chaining. And I can look at the source. And nice thing is that you can see the source that I show you here, but you can also visualize it here. Let's say it's like a straight function after another function. And then I can, if I want to execute, I'll do it. There's no input because I'm not passing anything to my workflow. And I can say, let's log all the calls, execute, and now this is kicking off our orchestration. Now it's running, it's calling all the functions, and if we check the logs, and it's already succeeded. So you can see that the output is just a number 3. I guess you can trust me that this call the whole chain and in the end get this number 3. But if you don't trust me, you can also look at the logs. And in the logs, we should see if they come back quickly enough. But we should see some calls that are being made to various functions. Yeah, well, this is the result of the success. But where's the other calls? Yeah, multiply function, input was this, stuff like that. So it seems like things are happening. All right, so that's workflows in a nutshell. And the rest of the stuff is just talking through this. So maybe I'll go through this quickly. So basically what we did is that we created the steps, define what happened, just chain them together. And you see how that works. You can do other things like serverless pause. So let's say you need to call a function and wait a little bit before calling the next function. So you can add a wait easily between your steps. And you can parse the JSON between your steps that I show you. You can get the body and the result pretty easily. Now, on top of this, you can add errors and retries around your steps. So if a step fails, for example, you can try and catch that in your definition, and you can apply the retry policies. And you can also apply kind of how to retry. So if you want to do a exponential back-off kind of policy, you can easily do that. And you can do things like success and error kind of things. So let's say the shipper function returns an HTTP code that you deem to be successful. Then you can route that to notifier Cloud Run service. Whereas if it's an error kind of code that you define what that means, it can go to a pager, for example. So stuff like this basically if-else logic that we normally do in our code, you can do it as part of your orchestration. Yeah, and this is what I talked about. So the conditionals you can do, you can call third-party APIs, stuff like that. And finally, you can do sub-workflows. So you can define workflows that you can reuse from other workflows, kind of like functions in code that we define and reuse. You can have connectors to connect to Google Cloud Services, and these connectors make it really easy so that you don't have to do HTTP calls all the time. Instead, you can just say, create this virtual machine for me, and it will just create it for you from the connector. And you can do iterations. So let's say you want to call Twitter. You can call the Twitter API, get all these results back, and you can do a for loop around those tweets if you like. And finally, the callbacks is if you want to do a workflow where there is like a human in the orchestration. Let's say you have multiple steps, and then at some point you want a human to say yes or no. You can introduce a callback, and that waits for someone to call the callback for this rest of the orchestration to continue. So you can see there's a lot of useful features, and this allows you to do a lot of things in the orchestration instead of doing in the code. And we've seen how to deploy a workflow. This is how you do it from the command line, and this is how you do it from the console. But I already show you that, so we can skip it. Okay, so that was workflows. Now I want to talk about some patterns that I've seen in orchestration, and maybe show you some examples of that. And then finally, if we have time, we'll also look at a case study where we use orchestration instead of choreography and how it helped us a lot. So one of the patterns that I've seen in orchestration is to combine it with choreography, right? Like, I mean, in the example that I show you, I executed the workflow myself. But how do you actually execute it, like normally? Normally, something has to either call, a service has to call it. But typically, what I've seen is that some event kind of triggers the orchestration. For example, I have this image processing pipeline where the idea is that a user saves an image into an input bucket, right? So just uploads an image, and I want to process that image using a series of services. Now, these services, the first one is a filter function that takes the image and checks if the image is a safe image. So it's not like an adult image or some violent image or something like that. And it uses a vision API. It uses machine learning to determine whether the image is safe. So that's a filter function. The next one, called labeler, extracts the labels out of the image using machine learning again. So figure out what the image is about. The third one is resizer, that it resizes the image to a smaller size that I defined. And finally, the last function is a watermarker that takes the labels that was extracted and takes the resized image and kind of creates a new image with the resized image and the labels on top, right? So you see that these functions, they need to be called in a certain order. First, the filter has to be called, then the labeler, so on and so forth. So that's why it makes sense to put them into an orchestration, because they are closely related together. They go in a certain order. But at the same time, this orchestration gets triggered by an event, and that event is a user saving an image. So that event is captured by something called Event Arc on Google Cloud, which is an eventing kind of service. It gets captured by Event Arc, and it gets passed to workflows, and then workflows gets executed, and in the end, you have this image saved in an output bucket. So to set this up, just to show you quickly, and again, this is all on GitHub if you are interested. But to set this up, basically, first you deploy all your services. So you create your input and output buckets. Then you deploy your services. I won't bore you with the details, but the code is there. It's all C# if you're interested. So resizer, labeler, and filter. So I just deploy them. They're individual services that they don't know about each other and they don't care. And then you bring them together into a workflow. In this workflow, first, this workflow is an event-driven workflow. So that's the parameter that comes into my workflow. Then you define the steps that needs to happen. The first step is log event. This basically logs the event that I received from me, just to see. Then I extract the bucket and the file name from the event, because the event has that information. Then I call my filter function. This URL will be replaced when I deploy it. But I call my filter function with the bucket and file information. I get the filter response. Then I check safety. So I call. Basically, this filter response will tell me whether the image is safe or not. So what I do is I want to check whether the image is safe. So this check safety will look at the body and look for the safe flag and see if it's true. If it's true, then it will direct me to label, next step. Otherwise, it will just end the workflow, right? So you can see how I do those checks. Then if everything is good, then I call my label function and get the label response. Then I call my resize function and get the resize response. And then finally, I call my watermark with the bucket and file information from resize, and then also the labels, the label response input as well. So I'm using the resize response and the label response as inputs to my last function, which is watermark. And finally, once that's done, I just return the status code from each service, just so that I can see that they all executed correctly. So that's the workflow. And I show you how to change the URLs to the right URLs and deploy the workflow. So this is how you would deploy it. And finally, I need to connect this workflow to an event. And I do that with event arc. And I say that I create a trigger. And in this trigger, I say, OK, I want to create this trigger where the destination workflow is this workflow that I just defined with these event filters. So this event filter basically says anything that's saved into this bucket with this finalized event, which means it's a new file, basically, send that event to this workflow. That's what this trigger is about. So I already have this set up. And just to show you that it works, let me go back to my workflows. And I think this was image processing. Again, you can see how things are supposed to work. You can see the check safety, the checks, and if it doesn't work, it goes to end. But to trigger it, we need to actually create an event. And the event is just to upload a picture. So which bucket was this? I need to organize my project. Upload a file. Let's see, pictures. Let's upload this picture from Paris. Now this is being uploaded, and if you go back to our workflow and image processing, where is it? Ah, thanks. You can see that there's an execution, right? So that triggered the execution, and hopefully this will be done in a few seconds. But we can see the input. This is the event that it receives, the bucket and the data about the image. And then we see the output as well, the 200, 200, 200, 200, which means they all run and everything's successful. Great. And then just to see the actual image, let's see if it actually worked. I can go to, let me open this in a new tab. So let's go to the output bucket. And I should see in Paris, yeah, you can see that there's Paris 400 by 400, the Paris labels that I extracted using machine learning. But let's look at the end result. So this is the image basically that's resized and then watermarked with the labels. And if you look at the image, yeah, so it says Paris, Sky Tower, Skyscraper. These are the things that we picked up from the image using Vision API, and it's saved there. So it seems like it's working. All right, so that's how you combine choreography and orchestration, and then that's what I think happens in mostly. People usually combine the two. The second one I want to talk about is retries and saga pattern, right? So if things don't work, what can you do? And again, let's go to this GitHub page. I think that explains it better. So imagine that you have 3 services: the order service, customer service, and order service again. So what this does is that the order service has a create pending order. So when you receive a request, it creates a pending order. Then this goes to a customer service that says, okay, let me reserve this credit. Let's see if the user has enough credit to order this. And then if that works, then the order service approves the order, right? So it goes from pending to approved. Now, if you deploy these and if everything works, then you don't need any retries or you don't need any saga patterns. Everything just works. So it will always go like this. And actually, if I show you the order, I have these 3 versions. So if I look at my first definition, ordering V1, you can see that I create the pending order, I reserve the credit, and I approve I approve pending order. So it's just very simple calls. But if things don't work, then this is not going to work too, right? So what can we do? Let's go back. So let's say this customer service is flaky. Sometimes when you call reserve credit, it does reserve it, but sometimes it doesn't. One simple thing that you can do is that you can apply a retry policy, and you can just say, okay, if something doesn't work, just try 1 or more times. It depends however many you want to do, but usually 1 or 3 times is enough. So you can do that, and that resolves the transient failures, right? If something is transient, usually the second time you try, it will work. So the way you can do this is if you look at my ordering V2, here again I create my pending order, so there's nothing special here. I reserve the credit, but now I put that in a retry step. So what this does is that it makes the call to this, customer service, but it does that in a try block, and then it applies a retry policy. And this retry policy, there are some default policies in workflow that you can use. We are basically using this HTTP default retry policy. And what this means is that this retries with max retries of 5 on HTTP 503, which is service unavailable, along with other HTTP codes, which I don't know. You can check them out. But basically, this allows you to recover from this transient kind of failures. Okay? But what happens if things are not transient? Let's say you are here and you want to reserve the credit, but the customer don't have the credit, so it's gonna fail no matter how many times you retry. So that's when the Saga patterns comes into play. In Saga pattern, what you need to do is that you basically, if something fails, you need to compensate that failure. You need to kind of roll back what happened, or you need to take an action that kind of gets you to the previous step. And Saga pattern applies to event-driven architectures and orchestration as well, so it's not specific to orchestration. But one way of doing this is that you create the pending order, then you try to reserve the credit. Maybe you still apply a policy one or more times, just in case it's transient. If it's not transient, then you define what failure means in your service, and then you call this reject order on order service. So that's your compensation step. So if you created a pending order and if something doesn't work, your compensation is rejecting the order. Otherwise, it's success, so you approve the order, right? So that's the Saga, basically. And the way you can do this in orchestration or workflows is doing this. So again, we create the pending order, nothing special. We reserve the credit with the retry, just like before. But then we have this except. So if we have another HTTP failure that's not transient, then we get into this except block, and then we check what kind of error is this, and then we say that, okay, HTTP 500 internal server error is, for me, it means it's not a I cannot recover from that error, right? So if that's the case, then I call my compensation step. Otherwise, it's some other error that I don't know about, but I'm just going to raise it anyway. So this step will fail. It's still not great because things will fail, but at least in the cases where I know that it's a failure that I cannot recover from, I'm going to reject the order. So this is one way of trying to do Saga. I'm sure in the real world it's much more complicated and you need to do more things, but at least this gives you an idea on what kind of things you can do when things fail, either temporarily or in a permanent kind of way. All right, I'm running out of time and I have a lot of stuff to talk about. So maybe in the next one, okay, this one, in orchestration you have steps that happens one after another, but it doesn't mean that they need to be sequential. So you don't need to do one after another. What you can do is that you can actually parallelize these steps, right? And you should parallelize steps as much as you can. And I have this example where I analyze Twitter sentiment of tweets. Let's say you have different Twitter handles, 5 Twitter handles. You want to read tweets from these handles, and then you want to use machine learning to analyze whether the sentiment is positive or negative, right? You can do this sequentially, one after another, but it's going to take a while. You can also do it in parallel, where you can handle each Twitter handle in a separate parallel branch. And the way you would do this in workflow is, you define your steps, and then at some point when you need to parallelize things, you define what's called a parallel step. And in here, you are basically passing in the Twitter handle as the thing that's being parallelized, and then you do the rest of the things. So you search for the tweets, then you log them, then you process them, meaning you analyze their sentiment. And by the way, here I'm using a connector to just call a machine learning API, so that's quite easy. And then I'm calculating some scores, assign the results, and then in the end I return the result with each Twitter handle with their sentiment. I won't run this because I'm running out of time, but things are parallelizable. You don't have to do things one after another. And lastly, you can combine serverless with serverful. So all of the stuff that I show you with workflows is serverless, like it just runs as a service. But and it also works with serverless functions and serverless containers, which is great. But sometimes you want to do a long-running tasks that you can only do on a VM, because VM, you need like the big VM machine, and maybe you need to run it for days, weeks, months, right? You can't do that in serverless because usually in serverless functions and containers, there's a time limit. It's usually 1 hour or whatever you can run. But what you can do is that you can use workflows to kind of containerize the long-running task, run it, make sure that it's completed on a VM, and once you have the result back, just shut down the VM and get the result back. So in this model, you are using servers, so it's not serverless per se, but at the same time, that creation of the VM and running that long-running task and shutting down that VM is kind of abstracted away because you're using an orchestrator. And I have an example of this in this link, but I won't show you now the details. But it is another pattern that I've seen people use with orchestration. All right, I have this whole other section that unfortunately I'm gonna skip, but just to briefly mention what I was gonna talk about here is that we used to have this application called Piccadilly, which is a photo sharing application. And initially, we implemented that using an event-driven kind of approach, where the user uploads a picture that generates a number of events that goes to different services, and then in the end, we save the image and the labels and things, and we display it to the user. Initially, we made it event-driven because it felt like that's what we had to do. But at some point, we started getting confused because there's all these events and there's all these different event formats. Depending on which service you use, you get different event formats. So it was getting, even though it was a small kind of application, it was getting quite complicated to figure out like different event formats. And if something failed, we didn't know where in this flow things failed. So we rewrote that using orchestration, using workflows. So when you look at this diagram, it kind of looks more complicated, but actually everything inside this red box is one service workflows, right? So when you think about that, it's actually simpler. And what we did in this case is that the front end still receives the picture, but then it kicks off an orchestration that defines what should happen, and it does some of the things within the orchestration, but it also calls external services when it needs to do, right? And the conclusion of all of this is that once we did this, we really liked it. We went back from 3 different event formats to simple REST calls. We had less code, no event parsing, no image analysis, no garbage collection functions, less setup. Instead of like 3 different services, we could use one service. And the error handling became magically easy because when something didn't work, we saw that, okay, this step failed. And I knew exactly what happened in that step, so I could just go to that service and figure it out from there. On the other hand, there were some downsides. Because in orchestration, there's this like YAML that you need to write. So it's, code versus YAML. It's a debatable question. I mean, YAML is not the place to write code. So that kind of challenges us a little bit. And debugging, testing, and logging, stuff like that is not that mature on orchestration. So that kind of challenges us as well. And we lost the flexibility of eventing a little bit. I also put parallelism here because we didn't use any parallel steps, even though we could. But also the eventing flexibility, we lost that a little bit because now we need to change our orchestration. But overall, our experience was really, really positive. So if you want to look at this app, there's a workshop around it, so it's at this link. And then if you want to look at the samples that I showed today, it's on GitHub on Workflows Demos. And if you want to get the slides as well, it's on Speaker Deck. I'm out of time. Once again, thanks very much for being here. I'm really happy to be here. I don't know if you have any questions, but I'm around. Yes, I'm around. I'll be at the party as well, so feel free to find me and ask me any questions.
Yes, I think we'll take the questions afterwards, so thank you very much.
All right, thank you.